Hello, Internet! Welcome back to the same joke I just did but had to re-record. And this is programming theory. The whole thing behind this was I was going to do it sort of off camera, but I think it fits the lesson plan, just to sort of give like a basic insight into how I plan bigger projects. Now, generally speaking, I would do this on paper, do it on in my head, or just do it in code and write skeleton classes and stuff like that. But I don't think any of those three things quite fits really well, especially in my head, and my writing is atrocious. And I kind of want to do all the code from start to finish as part of the lesson. I don't want you to sort of jump in and see half of it already done, because I can't help myself really. So we will just do it like this and sort of see what we come up with. And hopefully it works out pretty well. If not, you will probably never see this, so it doesn't matter. So the basic gist of how I do planning is I figure out what my data needs to be, my interactions need to be, then I work out how to bundle those things into like classes or structs or some other data bullshit, and then figure out how to get user input, figure out what needs to go on screen, all that kind of stuff. Now, in the case of Battleship, I think it's actually pretty easy because the data is fairly simple. You have your maps, your boards, and where the ships are placed. So actually, let's actually just write that down, eh? So data, we have the boards. So that's one for each player. You have the ships, which is 5 for each player, each of varying lengths. Well, you have 2, 3, 4, 5, 6. I can count, shut up. And what else is there, really? Whose turn it is. Current turn. Which, I mean, it isn't strictly necessary to have that as data, but it makes sense to sort of have it as at least part of your thought process. I can't really think of much else there is. As part of the boards, you need to have, well, obviously the ships, that's part of the board, actually. You need to have previous shots for both players, so that you don't have the same shot twice. So you know if you hit a ship, and that kind of stuff. Now, I plan to do this with AI. AI with big, huge quotation marks. I'm going to try to make it as smart as possible, but it's basically going to be random shot. If it hits something, then sort of go up, down, left, right kind of thing. If not, random shot. That kind of thing. There's not going to be much smarts to it because I don't know how much real smarts you could put into it. But that's what we go. So data. Now, interactions. Let's talk about our interactions. So as part of when I first built this, I actually made it dynamically allocate a board. So you didn't have to have the standard, I think it's 10 by 10 board or 12 by 12, whatever it is. You can actually have it as big or as small as you want. Obviously, it became a bit cumbersome at that point if it was too small or if it was too big. So I don't think I'm going to do that. It doesn't really add any complexity to the code at all. It's pretty simple to do it as, you know, if you're doing a 10 by 10 or a 20 by 20 board, it's basically the same code with just the numbers replaced, and that's in two places, usually the X and the Y. So boards, one for each player. Yeah, that's fine. So the only real interactions will be just inputting shots, which will be an X, Y coordinate. So you'll have the board labeled. It'll be, you know, top will be 1 to 10. The left side will be 1 to 10. That'll be the Y-axis. That'll be the X-axis. And you just go, what X, 1, what Y, 5, and it fires, and it comes up with whatever happens. That's it. And you should also be able to... No, you don't really need to put in a function to check the board. You'd expect that the board will always be on screen when it's your turn, so it doesn't seem like a big deal. So we'll leave that. Maybe check your own board so you know what the opposition has hit. But once again, you could probably put that on screen if it's a 10 by 10 board. And you have 2 of those, that's 10 by 20. You have 3 characters each way, so 30 by 20 board plus, you know, it comes out to be about 40 by 40, and a standard console window, I think 80 by 120 or something like that. Layout. 120 by 30 actually. So 30 would work for that purpose, to always have it on the screen. So that's not really a big deal. So I think that's pretty much the only input we actually need. We might want to take a player name if you want to have like a high score table or something, but that's sort of a bit further in the future. Now let's talk about the outputs before we sort of talk about bundling this shit together. Now, when creating a game on a console without any real graphics, you've got to be a little bit creative, because it has to convey to the user what is actually happening, but it also needs to be simplistic enough to actually do it properly. So what we can do is, like, and this is what I actually did as part of, as part of when I first made this game, is I had something like, you know, this or just that is an empty square. Something that you don't know if it's a hit or a miss because you haven't hit it yet. So this is empty. And you have like that, it's a miss. And then you have that, it's a hit. And then you can have maybe that is a ship. Something like that. It doesn't really matter in the end. The most important thing is to actually have it, so instead of just having, you know, that should be it. Oh, I meant like that, because between one space and two space, it's a little bit hard to tell, especially if you've got 10 columns of spaces. So to have it with the square brackets around it, I think adds that little bit of graphical clarity, or as much as you can for a console window anyway. Now, there is a bunch of libraries to actually control specific parts of a console window, so it's not just, usually you'd have to just write out enough blanks to clear the screen and then write your stuff, and then it'll be in the same place. But there are libraries, and obviously there are ways to control the console windows. You can go, all right, this square here is now going to be this, and then it doesn't have to keep redrawing. I will look into that, and if it's too complex for this kind of like early stuff, I'll leave it. But it would also be a very good example of how to incorporate other people's code into your own. And if you don't know what a library is just a bundle of someone else's code in this context. So my game engine technically is a library. It's actually literally a library as well. In programming terms, you take it and you import it into your code, and then you use the functionality it gives you. All right, so let's talk about our classes, or our data bundles, or whatever you want to call it. It doesn't really matter. Now, the obvious ones here are the data that we've listed. So we have boards, a board, not boards, boards. And what does a board have? It has an X size, it has a Y size, and it has an array of size X, Y for the squares. So you know if a square has been, if it's got a ship in it or if it doesn't have a ship in it. Now, you're probably thinking, well, all right, let's go back to that. So array of size, whatever, for the squares. Okay. So now we need to know how to, like with the XY array, so you're going to think of that as a two-dimensional array. I'm pretty sure I went through that. So it'll be like 0, 0, is that one there, then 0, wait, no, that's 1, 0, 2, 0, 3, 0, then that's 0, 1, 0, 2, etc., etc. And those are the squares. They represent the board. They're one offset because they're 0 based, but that's fine. So we can just go, I can't do like that, 1, oops, 1, 2, 1, 2, 1, 2. So that's a very, let's just make it 2 by 2A. That's a very basic thing, two-dimensional arrays, so hopefully you understand that. Yeah, so the squares themselves, do we want to represent that as data, or like as a separate class? Do we want to have like a list of ships that we go through? Because I'm thinking this one here, the array of squares, that'll be for if there's been a shot lobbed there or not. But because it doesn't really need to represent like a ship, like a big long ship on the screen, it needs to go square, ship, square, ship, square, ship, square, ship, square, ship. Might not be necessary, might be able to cheat it to make it a little bit easier. So if that's the case, we could have a square class, which just says if it has been hit and if it has a ship. So that reminds me of the interactions here. We need to be able to input ship positions. So we need to actually be able to ask the user, where do you want your 2 square ship to start? Where do you want your 3 square ship to start? Do you want it horizontal or vertical? So start position, horizontal or vertical. And that's pretty simple. That's just your CN kind of normal stuff. So a square, so array of square of size that. We have a square class now. So this should hopefully make sense when we go to doing it. If it doesn't sort of fit the needs of what we're doing, we can change it. This is obviously a lot of speculation is being done. And in the real world, if you go to actually make this and it doesn't fit, you throw your plan away and you do what actually works. The plan is more of a thought exercise, especially when you're doing it with multiple people. At work, for all the jobs I've done, it's always you plan with a couple of people, or you write a plan and you send it to a few people to get feedback, because people might have better ideas than you. There's nothing wrong with that. People might have different ideas. People might point out something that will or won't work, and this is all normal. There's no need to have an ego about it. Your ideas will be good some of the time, bad some of the time, and they'll be neither some of the time, and someone will be able to improve on them. And there's definitely nothing wrong with that. Oops. So what else do we need? We need the player. Why do we need the player? Let me just take a ring. We need to be able to say, it's this player's turn, request an action, request a square to hit off them, or request ship positions. So able to request shots and able to request ship positions. Now, if this was just a 2-player game, you would just not bother with that. You just go on a loop, CN, player 1, your shot, where do you want it? And loops to player 2, then loops back to player 1 and back to player 2, like that. But because we're putting in AI, you want to have some kind of generic control. Once again, it's not entirely necessary to have, but I think this is a good way to actually use base classes and show you a way that they're actually, inheritance, and show you a way that they are actually useful in a real world scenario. So we'll end up making a player controller, which will be a base class. And it will be abstract. It will be abstract because we don't want people to be a player. They will either be a human player controller or an AI player controller. It really shits me with the code style that I have when stuff like this happens. Because I want to have, like, AI is an acronym and I like to have it capital A, capital I. But because it's camel case, I go A, lower I, capital P. And it irks me, but it's like I have to. Or if I have like, and this will probably happen as part of this, if I have like X position, or get X position, like that. That shits me up the fucking wall having the 2 capitals in a row there, because it's not an acronym. XP in this case is not experience points. Anyway, I'm ranting about fuck all, but I'm insane. So this will be, the human player controller will take input from screen, from console I should say, so from the player. That's simple. So this will have a nicely formatted prompt. It will take the input, it will validate it, and it will send it off to the game. This will do some AI magic for requests. Whatever the algorithm is, it's irrelevant. It just needs to implement these 2 things. And then lastly, and this is something I've actually been tossing up since I started thinking about Battleship. Is, do we need an overall game class that manages all this? You could have just your main function go and set everything up, loop through everything by itself, and it will know when it's finished or when it started, when it's finished or when it needs to keep going. But it makes more sense for from a reusability standpoint. If you want to embed Battleship as a fucking Easter egg in your console app for some reason, then you can just import this class and go off and do that. And I think that makes a lot of sense, not to import it into your fucking console application, but just to have it as its own self-contained entity. It makes a lot more sense. My daughter's asleep. She's very cute. So this will manage turns, manage game stages. So the input stage for the ships, and then the fighting stage. So that should be game states, I should say. And then on game over, do profit, whatever. So this is, what did I just say? It was ship positions, battle, game over. Now, what else does a game need to do? I don't think anything else. Then exit. I guess it's probably something smart to do. Now, we haven't really spoken about states or application states or state machines. They are a little bit advanced, but we could do a pretty compressed, compacted version of a game state. And I'll explain those to you now, what a game state actually is and how it works in the sense of a game. So when you think of a game that you play, you have states that are like main menu, loading screen, main game, pause menu, options menu. Those are all different game states. And depending on how you want them to work, in my game engine, in the game I'm making now, they stack on top of each other much like a program does. So the one at the top has control first, and you can decide whether the ones below it get any kind of control out of it. So say for instance a loading screen. Now generally speaking, a loading screen, you don't have any user input, and all you do is just load stuff into memory and display on the screen the loading bar, whatever. So you don't really care that the state below it, which might be game start, because you might have a start state that sits there and makes sure the physics engine's running properly or something like that. So that's not how I would structure it, but it's an example. But then you get into the game and you hit pause. So then you're on your pause state, which has taken control from the keyboard and mouse, and it's rendering its menu. But underneath that, you still want the game to just render underneath that. So the game will be paused, and you'll be able to see that the game's paused behind it with like a glass effect or something on it cool like that. And then you want it to render. So depending on how the game is structured is how the game states sort of interact with each other. But generally speaking, it's just like we switched over to the main game state now. So this is what's going to happen. This is what's going to render. This is how the controls are going to work, and et cetera, et cetera. In the case of this game, there'll only be the 3 states, because it's very simple. Which, I mean, most games will only have a few states anyway, unless I'm doing it wrong, which is entirely possible. And then you have our game states. So the game states will be, what did I say it was? Actually, there'll be 4 states. So start. So the welcome screen, because why not? So the start state, the positioning state, just call it positioning, the battle state, and game over state. And each of those will have a different set of interactions and a different set of data to go with it. The hard part with this kind of stuff is being able to manage data between them. So the game here will probably manage the states, and it will pass data to it. It'll be like a data bundle, which will have just the board and the player controllers in it or something. which once again, this is all in theory. I haven't used game states like this before because I haven't made really a game with any kind of game states. We've done very basic stuff. When I say we, I mean me. But I haven't really made much game stuff. I've worked too hard on the game engine side of it to actually know too much about the making of the game stuff. So I'm sort of learning as I go along. So hopefully it works out okay. But with the game state, we're going to need like an enter. So this will be abstract as well. So what happens on enter? Render, input, and on exit, maybe. So something happens when the state is entered. So when the game starts, it'll present this. When the ship position thing is started, it'll do this. It'll set up something. On exit will be the opposite when that part is finished. What we do with user input and how we actually render stuff to the screen. All right, cool. And then the last one is probably the state data bundle, which I just spoke about. Which probably just contain the board and player controllers. Don't really see any of this other stuff that it actually needs because the board holds the squares. Yeah, I think that works. So yeah, that's I think pretty much it for like the basic planning. I can't really think of much else for that. So that's like the base of that, okay? But what about how the game loop would actually work? Now, if you haven't heard the term game loop before, the game loop in terms of as an end user is how the game actually runs, how you interact with it, how it interacts with you. In the terms of from a programmer's perspective, the game loop is what happens every frame or every interaction in the case of a console application because it's not rendered every frame. So it'll be, well, what would it be? It'll be, so actually let's start with startup. On startup, what are we going to do? We're going to create the game class, which in turn will create the state engine. And I'll explain the state engine when we get to it, which in turn will enter the start state. That's pretty much it. The game states, we need a something like that, something to actually make it change the state. Change state. Cool. Because the state itself needs to request that it be switched out. Like it is finished. You've hit the start button on the pause state, and it needs to be able to tell the game, okay, I'm done. Go back to what you were on. Yeah, that's literally all that needs to happen on startup. The game loop just needs to be render state, and then input state. So that's these two functions here. They're a bit, they're a bit shitly worded. So let's change that. And that's really it. The game states will manage the rest. But when there's an input from the user, or from the controller, or from the state, I should say, actually, because it's not guaranteed to be either of those things, it will then go back up to render, input, render, input, render, input, until it switches out the state or it exits the game or something like that. So probably on game over, just go back to start. And the start menu will have an exit, etc. All right. What else is there to consider? I can't actually think of anything. This is a very simple game. Well, let's talk a little bit about AI then. We're at the point now where we can just talk about AI, I guess. Ooh. The neighbor's kids are playing outside. If they wake up my child, they will strangle them. Because they always do it. So the AI, it needs to be able to pick ship positions, which actually reminds me, all of this, I placed in the ship positions and battling will need validation, so that when you input a value for a ship, you can't have ships overlapping, and you can't shoot the same square twice. That would be silly. But that's all part of the game, I guess. So AI, what does it need to do? It needs to be able to place ships, and it needs to be able to fire shots at opponents. So how do we place ships? There doesn't really need to be an algorithm here. Well, everything is technically an algorithm, but there doesn't need to be any smarts to it. It's random. It'll be random. So randomly pick X, Y, and direction. Validate. Repeat if necessary. I spelled necessary correct? I don't think I did. Nope. Always get that wrong. Pretty simple. It's fairly simple. You just go, all right, 2 random numbers, 3, 5. All right, I have a 3, and then we'll go left. I have a 6 length ship that can't go there. Or 2, 2. I have a 2 length ship, and I go right. There's already a ship there, so we won't do that. And then whatever. When it's validated, it's validated. So how do we fire shots at an opponent? We're going to copy this. If there are no undestroyed ships. Or let's do a proper branching thing. That's pretty simple. Randomly pick XY that hasn't been hit. But if there are undestroyed ships, if you know that there's a ship at 5-5 and you don't know what direction it's going in, so I guess we have to try to track that as well. So if you know what direction it is going in, so if it's going top to bottom, but see, this is where the challenge of AI comes in. If you have 2 ships on the 2 columns above and below each other, and it goes down, down, that one's going to be a miss, and that one's going to be a miss. So then you have to sort of readjust and say, no, they go the other way. So we'll see how I go with that. AI isn't exactly my strong point, but we'll see. So if we know what direction it's going in, fire in that direction next to it. If we don't, then pick, sorry, that should be else. Pick a random direction. That seems pretty simple on paper. Oh God, what am I doing? No, dig up, stupid. I feel like I've made a mistake trying to do this. But I have done this before. I did it with a random AI algorithm, so it just picks a spot and shoots. Which reminds me about AI. Do we want a difficulty? Do we want difficulty? Because we could very easily do, you know, if you're at the easiest of easy difficulty, random pick XY. If you're at a medium, it randomly picks, and then it's sort of just, if you hit a ship, it'll go, you know, in one direction. And then hard, it's like, okay, I know I've got a 4 ship left. There's only 3 spaces here, so the likelihood of that is low, so we'll go somewhere else. But that seems extremely excessive for like a start project. So maybe we won't do that. That seems stupid. So we won't do difficulty. I don't think there's anything else. So we have the game starting up, we have the game loop, we have AI, we have all the data we're going to use, we have the inputs, the outputs, and the interactions, which is the input. Yeah. I think this is pretty much done. So when I actually get into making this, you'll see how this also comes together pretty quickly. What will end up happening is I'll write probably this class first as a skeleton, and then this one, and then probably that one as well, and then those two, and then I'll sort of fill it out from there. When it comes to some of this stuff, I'll sort of show you how stuff is structured properly as well. Things like not having what's called magic numbers and magic strings, which I will explain during it. Having things like using, I'm not going to use namespaces. Why the hell was I thinking namespaces? I don't know. Just how everything is structured, and how it all fits together, and sort of how the hierarchy works, how I personally code stuff, and hopefully my fingers work well enough that I don't make 1,000 typos that make it go for 8 hours longer than it needs to. Looking at this now, I'm guessing I could probably get this done in a day, maybe less, but it's always different when you jump into it. So we'll have to see. But I hope this has been somewhat informative. As I said, I wasn't really planning on doing this. But I think it should hopefully open up your mind a little bit to how it all works, and how the thought process should go for you, or might go for you. You might be very much different. You might start with classes and go to data, or you might start with outputs and then go to inputs and then go from there. It doesn't really matter. As long as it sort of kickstarts your thinking process, then that's fine. As I said, you can do this on paper, do it in your head, or do it in code. I usually do skeletons of classes in code and write comments and stuff instead of actually coding anything, and that sort of ends up being my documentation as well. But yeah, that is it for this one. It's actually gone pretty well, and I'm shocked because I really wasn't expecting to do it. And I will see you hopefully next week, or which will probably be this weekend by the time I put this up, to make Battleship, and hopefully it'll be fun. And I will see you guys next time.